Good afternoon and welcome to our Gas Distribution System Insights webinar. Today, Jeff Dewitt will provide some basics on gas distribution systems so you have a foundation of knowledge. Jeff joined Swagelok in 2017, where he has served in a range of capacities, including large capital project management for semiconductor capacity investments, automation, and infrastructure. Over this time, he has developed expertise in topics including industrial gas distribution system. Currently, Jeff serves as an application expert and presently product manages the Swagelok gas distribution program. And now, here's the Gas Distribution System Insights webinar.
Thanks, Dan. Hello, everyone, and welcome to today's webinar. It is going to be all around gas distribution system insights. That's largely born from Swagelok's time supporting a wide range of industry. I'd like to, first of all, take a moment to extend a word of thanks to both our hosts as well as our participants. You know, it's with thanks to your continued engagements that makes things like this possible. I do expect to run around 31 minutes. So if you do have a hard stop at the half hour, feel free to jump off. And at the end, I'll be happy to field a question or two. Today's webinar is going to be informative, and the theme is all around opportunity. It's opportunities that we see for the owners and operators of our gas distribution systems. You see, my plan is to share a few examples, a few useful examples to illustrate opportunity. Please know that these examples come from customers who have given us prior approval to share images, and no otherwise identifiable information will be shared. You see, the way I like to put it, I view Swagelok as a global network of problem solvers. By the end of 2024, we expect to surpass over 400 technical resources in the field. This is field engineers and application engineers and technical specialists. We touch every part of the globe, and as you already know, we're in your backyard. We see lots of opportunity every day, and we'd like to share some of these trends with you. As you've heard, my name's Jeff, and I'll be your presenter. I've been with the company for a while, and believe it or not, I'm joining you from Cleveland, Ohio. It's really thanks to my roles and past customer exposures that I've been able to be involved with a variety of general industrial gas distribution systems, and I'm very pleased today to be able to share some of my experiences with you. Gas distribution itself is pretty self-explanatory. It's a network of tubes, pipes, and a bunch of other important parts that transport that gas from its source to the desired point of use. When we think of sources, I think of things like bottles, but it can be compressors or other even cryogenic sources. And when I think of point of use, it requires something a little bit more precise than those variable sources. Generally, every gas distribution system can provide these basic operations, but at the core of it, the intent is to keep the gas contained, be able to provide the right pressure without restrictions to flow when the user calls upon it. Gas distribution is found in an array of applications and across many industries, but one thing that we see quite often is that these systems tend to be both overlooked and or sometimes misunderstood, and that creates opportunity. Now, there's a few paradigms that we see that help to explain these opportunities. In some cases, the ownership is just not routine. An example might be one group uses the system, but another one may maintain it or pay the bills. In other cases, a gas distribution system could traverse multiple jurisdictions. So say, for example, you've got a central gas utility that spans multiple buildings or departments, and the final system accountability sometimes is unclear. In other cases, they're simply deprioritized. There's a mindset of set it and forget it, whereas these systems, it's paramount that they enjoy regular preventative maintenance. Or lastly, what we tend to see is a lot of times these systems are constantly changing. Temporary becomes the new permanent. Your process and instrumentation diagrams and or mechanical prints, they don't keep up with the actual. And these paradigms explain opportunity, and these opportunities can come in the way of two risks for those owners and operators, both safety exposures as well as unnecessary costs. And these costs can come in a few different forms, so we're going to unpack those now. See, all opportunities are going to fall into one or sometimes a few of these buckets. Safety is always first, it's paramount, it speaks for itself. And we're going to share a really good example with some figures here in a moment. Now, cost saves are historical costs that if you can avoid them, they immediately go back into your organization's profits. So think of things like in the way of gas distribution, getting more out of the bottle, or spending less on your recurring costs, or reducing your leaks, or reducing the direct or indirect labor tied to running the equipment. And lastly, reducing scrap that's tied to production equipment that may benefit from those gas distribution systems. On the flip side, cost avoidances are things that really haven't happened yet, but they could be costly in the future. In the way of gas distribution, think of things like, oh shoot, I have a safety incident, or I've got to remediate a failure, or even we see a lot organizations failing to lean on key pre-engineered and turnkey answers and instead choose to do it themselves. Now, revenue preservation is another key area of opportunity. This is a failure to realize your revenue while a critical system like a gas distribution system is down. Think of the lost opportunity when you have a major outage to perform an emergency repair. The last, but certainly not least category of opportunity falls into reputation preservation. Let's face it, for every organization, their most valuable asset is going to be the reputation. Ben Franklin described it really well when he said, it takes many good deeds to build a good reputation, but it only takes one bad one to lose it. You see, reputation challenges in the way of gas distribution can come when there's bad press from a safety event, or there's a failure to deliver based on like revenue, and that causes bad feelings with the customer. Or my favorite, internal frustrations for those key maintenance staff that have to do constant triage and firefighting to keep up with those system repairs. So let's dig into our first example. I'd say at first glance, this looks like a pretty nice and clean bottle installation, but there are actually quite a few opportunities that I'd like to highlight. And these opportunities tie to trends that we see with customers all the time. The first thing that I see is a lack of adequate regulator creep prevention. Namely, there's no filter upstream of that regulator. And we're going to unpack this a little bit more in a moment. The second observation is really around a key safety insight. You see, high pressure gas injection injury is a risk for any operator that might put their hand under that vent discharge and open that red handled needle valve. High pressure gas to the tune of, in this case, 3000 PSI over that small area can easily penetrate the skin and jeopardize the tissue underneath. There's actually a US Department of Energy report, and it shows that high pressure gas injection injuries account for about 1 of every 600 hand traumas, and that most often affects the digits. And admittedly, it's something that when it happens to most people, they don't think twice about it. But if it's not treated immediately, it typically amounts to amputations due to the tissue damage. And that's amputations to fingers, hands, or I've even seen like lower arms removed. You see, the third observation, and this one's really important, is around an overlooked cost saves. Gas companies, they charge by the bottle and not by the molecule. So it's important that us, as owners of gas distribution systems, we seek to use up as much of the molecules in that bottle as possible. In this case, the customer was depleting a 6,000 PSI bottle down to only 3,000 PSI. Said differently, they were leaving more than half the molecules in that bottle. Also, that's about $500 per bottle of unused gas. Now, in this case, the customer was replacing these bottles about every month or so. So what's really cool is that Swagelok was able to identify this as an opportunity. The customer repurposed that residual gas to another application, and they were able then to maximize their dollars. It was like over thousands in savings annually. You see, in this case, it's helium. Helium is probably one of the most expensive general industrial gases, so it's very important that we be judicious about where that goes. I have a really interesting thought on safety. You know, safety risks are a top priority for every organization. They're always going to say safety first. But admittedly, in the US, we still carry quite a bit of cost to the employers when it comes to workplace injuries. They still happen, and they're quite expensive. You see, on average, recordable incidences in the US run around $44,000 in cost to the employer. And let's face it, gas distribution systems have lots of stored potential energy, which means that more than likely, if there's a failure and a safety consequence, it's likely going to be more severe. What's really neat is that we've assisted a lot of customers that lean into figures like this for building the business cases to help justify serious system changes that help to positively improve safety. Like I mentioned, I did want to talk about regulator creep, and it's important that we first understand what it is. The interface here in this basic pressure reducing regulator that really matters is that space, that small gap in between the seat and the poppet. It's what creates the pressure drop across the regulator. Now let's imagine for a second that there's some obstruction, say a contaminant that gets between that seat and the poppet. The regulator now gets stuck in an open position, and that's the primary cause for creep. See, regulator creep is a phenomenon where, really simply put, the regulator stops becoming a regulator, and that can cause some serious safety issues and/or can risk other downstream equipment. It just so happens that creeping regulators are one of the biggest reasons for regulator returns that we see. And when we open up those regulators, we tend to find things that look just like this. Metal flakes, largely from uncleaned NPT threads or even Teflon tape. And what's really happening here is that the regulator is becoming an inadvertent filter, and it's a very expensive one at that. So there's a few key things that we can do to protect against creep. In the illustration down below, we have a basic pressure reducing regulator, 2 gauges on either side, and a downstream isolation valve that separates the equipment from the regulator. The first thing we can do is add a relief valve on the outboard on the low pressure side of the regulator, and what that will do is reduce the pressure rise should regulator creep occur. That relief valve would be set to a pressure slightly above that low pressure set point. Now the next and single most important thing we can do is to integrate a filter upstream of that regulator. And full transparency, this is like the single biggest opportunity that we see out there in the field when it comes to owners and operators of gas distribution systems kind of doing incorrectly. Now, the last thing we can do is make sure that we've implemented the right provisions to service that regulator, because we know it's eventually going to need service. So providing an upstream isolation valve to complement the downstream, and having a provisions for appropriately bleeding off pressure so that regulator can be serviced is paramount. That upstream isolation valve is also really important, because another bad practice that we see is individuals using the regulator as isolation rather than using a true dedicated valve for that isolation. Now package those all into one common panel and you've maximized your convenience. Here's another really cool example. Swagelok was tapped by a customer with the problem they were having with a piece of laser welding equipment. In this case, the customer was welding a stainless steel joint. Now, this was a highly automated piece of equipment, and we're looking at this image. A back panel has been removed, and we're looking in through the backside where like the chuck head is. See, the customer was using nitrogen shielding gas that required less than 10 parts per million oxygen impurities to make sure that they could get a good weld. Well, in this case, the customer was experiencing weld discoloration symptoms that suggested that the oxygen impurities were well above 50 parts per million, and that was causing a lot of scrap for him. The customer had first actually verified that the quality of their supply was meeting the requirements. It actually measured in at below 5 parts per million. So Swagelok was engaged to help investigate, and here's what we saw. We almost immediately identified a permeable hose in the equipment as being the root cause. You see in that picture all of the blue hose, all that flexible PFA hose was highly permeable. You see, contrary to intuition, impurities can enter through the permeable membrane, in this case, the hose. All internal pressure, namely carrying nitrogen, is much higher. you see there's a partial pressure of those impurities coming from the outside, always working their way to ingress in just as the nitrogen can permeate outward. So it's really due to those partial pressures that was driving, the ingress of those impurities, and that was the customer's root cause. So the solution was actually pretty simple. In conjunction with the customer, they replaced over 40 feet of that blue polyurethane 1/4-inch soft tubing with some rigid tubing, as well as some stainless steel core hose for the vast majority of the length. And what that did is it fixed all their symptoms. There was an over 95% scrap reduction. There was some major productivity improvements, and it saved them thousands of dollars in the annual and was a very quick payback for that correction. Another opportunity that I really like talking about is organizations failing to make the best use of changeover panels for critical operations, which really is all about maximizing their bottle consumption simultaneously. You see, changeover panels are great for critical operations where you can't be down. They draw from a primary source and then switch over to the secondary once that primary has been depleted. While the secondary is being used as the source, you swap out the primary and you kind of keep going in that cadence. So these types of changeover panels are offered in 2 different flavors. You have manual, which requires some human interdiction, but at the same time, you have automatic changeover panels, and they work by sensing a low pressure in the primary or secondary source and then swap over as appropriate. There's also some other advantages to these automatic. So let's look at a real world opportunity. Last year, we were working with the customer with an application where they had a large volume of gaseous helium required for a critical operation in a few of their applications. This customer was spending over $2 million a year and annually, and they were using about 1 tube trailer per month. And as I mentioned, helium is quite expensive. The trailer was being delivered around 3,000 PSI, and we came to find that customer was calling upon the gas company to swap out that trailer at a 700 PSI residual. Now, as we talked, the gas companies charge by the bottle, or in this case, by the tube trailer. So we immediately identified it as a large potential cost save. Said differently, that customer was leaving over 1/4 of the molecules in the tank. You see, the customer had the best of intentions. 700 PSI equated to contingency operations for them of around 5 days. Now, 5 days also happened to coincide with the contractual leeway that the gas company was committed to delivering a new fresh trailer. So when we took stock of the customer's gas distribution system, we found something like this, basic P&ID. Thanks to our understanding of changeover systems, we were able to propose a very simple implementation that brought a lot of value. So by integrating a changeover panel and bringing in a second tube trailer, we could now justify a much lower basement level for depleting those bottles, meaning where we were going to get more out of each bottle source. The low limit on the tanks, the 100 PSI, was now driven by the compressor. And speaking of the compressor, we were also able to advise on an or upgraded compressor and some accumulation volume that really helped to address some other customer pain points. And what's really neat is that this ultimately amounted to a tremendous value for this customer. Over $250,000 in a year saved, a very quick payback on their investment, tremendous revenue protection, and a nice carrot also with regard to environmental and social governance. Another really cool example that demonstrates a key lesson that we see all the time. Know where your gas is going, and as a consequence, know where your dollars are being spent. You see, Swagelok was on site with the customer about a year ago, and they shared an initial intent that they wanted us to do a very large survey of a facility low pressure gaseous nitrogen system. This customer was going through so much liquid nitrogen to support this gaseous system, that they were receiving a 5,000 gallon delivery of liquid nitrogen almost daily, or almost every working day of the week. You see, this customer was also investigating a capacity increase to their storage to kind of reduce their delivery dependency. This was a very big facility. It had miles of 2-inch and under tubings and fittings, and we, along with the customer, were trying to brainstorm ways to evaluate this system to kind of maximize their value. We didn't want someone sitting there for a career trying to evaluate the entire system for leaks and the like. So we ended up assisting the customer to strategically select and locate some mass flow meters at specific locations in their facility. So namely a mass flow meter right at the inlet to the facility, as well as locating it near some suspected big users, where this, again, being a large facility, these suspected big users were like smaller sub-buildings of labs and other units. Here's a couple images of those flow meters. They included digital display. I think that's showing in standard cubic foot per minute, along with an integrated data acquisition system. So after a few weeks of data collection, we saw a few key trends. First of all, the weekly flow rate consumption, meaning that flow meter at the entry to the building, thankfully was closely matching the data that was given by the gas company. You see, the gas companies, a lot of the times they have built-in telemetry into their systems, and they can monitor real-time the liquid levels in the tank. So it was really important that we knew that our data sets closely matching theirs. The next thing we saw was that, no surprise to the customer, those big users, as they suspected, were indeed big users. Now, the most surprising discovery that they saw, however, was how much the weekend consumption rate actually was. You see, when the lights were off and no operations were taking place, the facility was still drawing over half of the flow rate of gas that they would during the average weekly rate. And at about a cent per standard cubic foot on nitrogen, at 52 standard cubic foot per minute, 24 hours a day, 365 days a year, that's over $275,000 in annual nitrogen that's unaccounted for. And what was really interesting is that those big users were especially guilty of a lot of weekend consumption while the operations were stopped. So in conjunction with the customer, we discussed evaluating a smaller building for gaseous nitrogen use within their gas delivery system to really see if leaks could explain some of that parasitic load. And in a one-day survey with some of our field specialists, we found a handful of leaks, and those leaks probably added up to, say, around 4 standard cubic foot per minute, but it wasn't the 12, 13 that we were measuring. And I think that that's really important because, the customer was able to prove, contrary to their suspicions, that it actually wasn't the leaks that was causing the problem. And what that informed the customer, or helped them to then realize, is that it must be due then instead to some of their constant purging that they have tied to those gas systems with equipment inside that sub-facility. And now that the customer was more informed, they can make better decisions, right? Better decisions around how to add capacity, as well as maybe identifying opportunity for them to challenge some of their current purging protocols. And what's really nice about this survey for the customers is they were able to quickly tighten up what was found, and they got a heck of a value out of it. They cleaned up over $15,000 a year in annual nitrogen leaks, and it was a really quick payback on that service. I'd say aside from both convenience and freed up labor, we see a lot of customers missing out on a tremendous cost avoidance tied to leaning into pre-designed and pre-engineered panel offerings. So let's imagine for a second we have this very pedestrian gas panel. It's a single stage pressure reduction. Let's imagine for a second we have all the key details we need to design and build it. We know what pressures, what temperatures, the media, and the flow rates required to make this thing happen. Well, it turns out we can express some serious spendings avoidance over kind of a DIY, build it yourself type of thing. without question, there's a lot of value in not having to do the engineering yourself. There's also logistic savings in the way of reducing the amount of POs as well as the amount of inventory that you as the final destination have to deal with. One PO and one crate to unbox is a lot easier than multiples. And last but certainly not least, a lot of times with organizations that we see liking to do things themselves, they love to bring in an outside party like a mechanical outfit, a pipe fitter, tube fitter, a plumber, who generally have much higher labor rates over that of like an OEM that can provide you these sorts of things turnkey. In the aggregate, there's a heck of a lot of cost avoidance here of leaning into those pre-engineered solutions. Admittedly, the overall cost avoidance here easily exceeds the total price tag of the panel. Said differently, why pay double? Swagelok gets a lot of questions about hydrogen and oxygen and safety and gas distribution, and I did want to take a minute to talk about both. Swagelok admittedly has enough experience and expertise with both molecules. We could spend weeks talking about it, and I'm not going to take that time here, but I do want to touch on about 60 seconds worth of material. Hydrogen and oxygen, they've got a lot more in common than being the building blocks for water. They're both diatomic, widely abundant, and carry some safety preconceptions. The spirit of any good gas distribution system is to avoid the presence of all three legs of the fire triangle. And in this case, hydrogen is a fuel on that leg, and oxygen, no surprise, is an oxidizer. You see, hydrogen is a problem because it has a wide flammability range in air. It's also a small molecule, so it is hard to contain. On the flip side, oxygen, especially at high pressures and high concentrations, can make a lot of things that you don't conventionally think of as a fuel into a fuel. And in the case of gas distribution, that means things like stainless steels that are conventionally used. Now, in both molecules, both deflagration and detonation ignition mechanisms are important to avoid, whereas oxygen has a couple of well-documented ignition mechanisms that are well understood. In the way of mitigating risks around gas distribution, I'd say the one thing that's a common misconception is that it's much more than just the material selection when it comes to safe hydrogen and oxygen operation. System line velocities and limitations thereof may drive tubing sizing up increases. Certainly component layout, what components to include, and specific component features can be driven by the molecule that we're carrying. And also, operating processes to complement these systems is paramount. Think things like purging operations for hydrogen or proper preventative maintenance for oxygen, where the goal is to both preserve cleanliness as well as avoid those ignition mechanisms. And last but certainly not least is definitely the importance of risk assessment. So think of things like both design and process failure modes and effects analyses that will hopefully ensure that we have the engineering controls to mitigate those administrative potential failure modes. We've talked a lot about opportunities that we see among organizations, opportunity, room for improvement. But what I'd like to share now is some behaviors that we see in the top organizations and customers that we serve. The first observation is all about organizations, including gas distribution systems, in broader facility-wide risk assessments. You see, the failure modes of these gas distribution systems, they're weighed in the way of consequences to things like safety or cost avoidances or revenue preservation or reputation preservation. And a heavy amount of importance within these organizations is put on reputation. There's a 2007 Harvard Business Review article that notes that a reactive approach to reputation threats is not reputation management at all. Said differently, if you're not proactive, you're missing the mark. These risk assessments then help to justify the design and framework for these preventative maintenance of these systems. That's also really cool. Top organizations, they also stand up metrics to go along and monitor their gas distribution systems. And these metrics go much beyond things like how much do I spend or what's my usage. They look at things like we saw, flow rates. They look at uptime, system uptimes. They look at refill rates. And they also look how frequently is the gas company on my site interdicting? Because let's face it, that's a risk if you're dependent on someone else. Lastly, organizations really lean into routine inspections to complement their preventative maintenance. So think of inspections during initial installation, maintaining their process and instrumentation diagrams and other mechanical prints, as well as inspecting for leaks on a semi-regular cadence. You see, they closely monitor these systems because they know the dependence and they know the value that they bring. I'd offer that Swagelok can provide a wide range of solutions to suit your gas distribution needs. Our products are awesome, but one thing that I'll highlight here in a second is a really neat program that we have to provide both pre-engineered and highly configurable standard panels. Our limited lifetime warranty is really awesome too. What's neat though is we can do a lot more than that. We offer a wide array of services to help evaluate and advise on the health, safety, and performance of your gas distribution systems. And most importantly, we have this global expertise that can offer you these insights and perspective and industry awareness to help you see these opportunities that might otherwise simply be looked past. I share now this elegant example of Swagelok's commitment to gas distribution. A few years ago, Swagelok launched a program that offers these standard and highly configurable panels for a wide range of gas delivery needs. In this view, we have two different applications where we can apply 4 different panel types. Think like a panel for the bottle connection and manifolding that gets you a filter right at the bottle, or think a primary near bottle pressure reduction, either single stage or 2-stage, a highly configurable automatic changeover panel, or a point of use final stage regulator panel, say for example in a laboratory when you've got a very sensitive gas chromatograph or mass spectrometer and you want to be sure you've got that pressure dialed in, because let's face it, the asset's a ton of value and we don't want to over pressurize anything. The speed and collaboration that we can enjoy with our customers is what makes this program so powerful. It turns out that actually Swagelok's configuring almost 300 panels a month globally for all sorts of customer applications. At your site with you, real time, we can configure these panels using our web-based tool. And what's really neat is it spits out like a complete part number. And that's become very popular among those who are doing things like building information management. You're building a new lab or a facility, or you're in the general construction game, or you may even manage a laboratory. A single part number over managing a huge bill of materials is highly powerful. This system then automatically outputs a complete design. So we've got a light CAD version, you get a bill of materials, as well as the complete SolidWorks pack and go. With that SolidWorks pack and go then, contingent upon your needs, these systems can be customized. So imagine for a second we have a changeover panel and we want to add some simple and-on lights and a pressure switch so that we can be more automatically alerted of a bottle outage. Last but not least, then, Swagelok can turn around these pre-built and tested panels to really maximize your convenience. That's the end of the words that I have to say for the day. I just wanted to say a tremendous thank you to all of you for sticking with us. I'd highly, highly encourage you to reach out to your local Swagelok team using any of the information shown,